Okay, welcome to our webinar. This is a huge honor for me because today we have Mika, of course, our colleague from Tampere University, but also we will have two speakers from United Kingdom. And I promised that I will only speak for a couple of minutes. So my name is Jaakko Kinnunen. I work in Tampere University and I'm the project manager of our innovation platform. The platform is called CoreLab. And CoreLab's main function is to bring companies, municipalities, and the university closer together. And we are trying to help a university to create new projects and also help the companies to improve the business models and, of course, learn together. And cooperation is the key word here. And before we start, and I will thank everybody after the seminar as well, but special thanks to Mika Lehtimäki because his connections to United Kingdom has been valuable when we put all this together. And our topic today will be artificial intelligence and real estate investment and financing. And this is a topic that Mika knows a lot more than I do. So without further ado, I will give you Mika Lehtimäki from Tampere University. And one more thing, we will record this event and we will publish it on YouTube later. So thank you for everybody joining. And now, Mika, please, the stage is yours.
Oh, brilliant. Thank you. So I'll be giving a short presentation, just 10 minutes. So I'll be really brief. But let's just share the, we have much more knowledgeable experts, Richard and Lawin, getting in depth into the specifics of what's going on. Let me just ensure that. Can you see the presentation on the screen? Oh, brilliant.
Yes.
All right. So we're going to talk briefly especially about the research we're doing here at Tampere University with AI and real estate finance and investing. So I'm a research fellow here. I'm a long-time attorney and I also do coding every single day with these systems. So I'm kind of deeply involved in the development, and we have a lot of projects going on. But let's dwell into the actual topic. So it's really been previously about location, timing, and capital real estate. But for the last project that we've done, and we've seen a number of those working with the companies and cities, it's also about algorithms. A lot of people are doing these things, but to be fair, and something probably that Richard will mention is that there are limitations, and overarching systems are really hard to build. So what we're really doing and what is the center of the research is kind of a niche solutions to real estate investing and financing. And it's really moved on from being a back office function to a everyday function. Most people are just using Copilot and software like that, but there are a lot of applications coming up and there's a lot of good research, especially this year on the topic. So we have 6 main areas of application here that are important for real estate investing and financing in our research. And the first one is where we apply the systems is investment analysis and market forecast. So it's mostly about analyzing macroeconomic data, demographic trends, and market changes. So that's the realm of machine learning and predictive analytics. Then the second part is portfolio optimization and risk assessment, which is mostly about dealing with the funds and investors, how they deal with the portfolio, deal with the diversification, making that better using the AI systems, tools, and for example, market trends, sales trends, like linkages to interest rates and all. And the third one is automated transaction discovery. And this is something that's not really for financing and investment, but mostly about transactions. So finding deals quicker, making comparisons quicker. Fourth one is enhanced transactions and negotiations. There are a lot of good platforms like Harvey AI on the legal side, dealing with the making it faster to do documentation, for example, with the investments. automated asset management, something that we're really working hard with, is something that once you own the asset base, how to make operations more efficient, increasing the net operating income as a result. And the final is ESG integration, which is environmental, social, and governance. We have a lot of regulations in the field, and it's easy to code those in due to the fact that as a lawyer, I see that once we have a set regulatory base, it's easier to put in the ESG part into the analysis as well. So it's really about machine learning and predictive analytics. We are using artificial intelligence with regular tools for some like portfolio optimization and strategies. We've learned that deep research is currently the best way of getting really in depth into the real estate investing area. So a lot of good companies, for example, Keyway in the US, you find a lot of real estate data about sales, assets for sale, and you, for example, they include AI system on top of that, analyzing the relative value of real estate. So Keyway, one of those, Testimate in the US as well, uses a lot of machine learning for rental properties and sales data and sophisticated AI. What we have in Finland is, for example, hintataso.com, which tracks all the price levels in the pretty much all of Finland. It doesn't have the AI tools now. One of the researchers here set it up, and it's a wonderful basis for as a tool for the AI to use in real estate investment. So just an example, research process flow, how we see this going forward. This is an example of what we do. And I'll give an example after this slide as well. So usually what we have is inputs to the system, which is risk tolerance of the investor, return target, how much money they want to get, annual return, constraints, and current portfolio. Then we use a lot of tools like macroeconomic data and microeconomic data as well, transaction data, to kind of bring in the additional insight into the system. Then we usually, what's a good way of going forward is using machine learning for predictive analytics, correlational analysis. That might be just regular statistics or logistic regression, but machine learning works pretty well with some of the more complex issues. And then we use two phases of our artificial intelligence, which is prediction models. For example, what it means, what the machine learning and the data sources tell. So they kind of give the overall analysis, and after that use an optimization algorithm for optimal portfolio allocation. So that's how we kind of, on the research side, are approaching this area. This is an example. If you have 80% of apartments in Helsinki, you see the percentages over there. It might be that the optimal allocation suggested by AI reduces the housing in Helsinki, gets into the retail, logistics as well, and the return to the risk level might be lower in that sense, and bringing it to the line of capital asset pricing model more easily. So it makes it more efficient to carry out the analysis for the allocation part. This isn't an implementation, and what is different now is moving from kind of a backlog of information, old information, to reactive information. So for the maintenance and kind of operations and kind of how you maintain the property and your allocations, they can be more real time than previously. So that's good. Lenny, a good example from the US, using sophisticated AI and predictive analytics. On top of that, AI to deal with commercial real estate properties. What we're really seeing is, I think, real-time self-learning prediction models. Hard to develop. Richard will probably tell what might be wrong with them or the limitations, which is a good thing. We have Urbanist AI, for example, now developed by one of our researchers who does multimodal urban planning, which can be used as a basis for investors getting into the deals as well. two main technologies that we use that are obviously there are many and they're popping up all the time is multi-agent systems, which just means that we have, for example, a data acquisition agent, a market analysis agent, property valuation agent, due diligence, and the system calls them in sequence to determine what are the questions, what are the properties needed. So multi-agent system is one. Then we've learned that for more complex like portfolio analysis and all of that, you need a research team and a deep research architecture. I think it appears currently provides the best way of moving forward with this. So it's really a lot of agents working together as a research team, providing solutions, for example, investment strategy. So it pretty much looks like that. What we are doing, we have multiple agents working on different tasks. They have APIs, which are connections to the databases, like market data, financial data, agreements, and all of that, and together determining the scheduled tasks for each, what the user wants to know. So this is the system that we are building in some of our projects that we are doing currently. Just a quick, I only have 10 minutes, so the last one is what we are doing here now is if somebody's interested, we have Invest AI starting probably early next year, large-scale real estate investing, financing transactions, and how AI can help them become more profitable and more marketable to the banks, especially to the banks we are facing here in Finland, a slight real estate crisis at the moment. Then we have data-driven regenerative cities, which is directed cities, but how they build, allocate together with the developers the best possible or most cost-effective ways of building areas, and smart spaces for buildings as well. So I think that was my brief presentation. Here we go. And I know I only had 10 minutes, so but I guess people could ask at the end probably, so that we can keep up with the schedule here.
Yeah, thank
Jaakko,
you.
Over to you.
Yeah, thank you, Mika. And we are ahead of schedule, so we have 2 minutes, I think. And if anyone has a question for Mika, just raise your hand or open up your microphone, because I think some people have to leave midway, so they might miss the chance. So, okay, Richard, please, you have a question for Mika.
It's the real estate crisis in Finland. I was quite intrigued by that.
Yeah, the transactions are low. Foreign investors have evaded Finland for the last 2 years. Open funds, real estate funds, most of them have closed, and level of building activity is really low. So we have obviously the interest rates are slightly higher, which affects building activity overall. So we do have that, in my opinion. People are saying that it's going to ease during the coming months, but I'm as a corporate finance attorney, I think that we're going to see a lot of bankruptcies early next year as well.
Sounds tricky. I mean, that sounds like a perfect storm to me.
Yeah, it is. It is, and making things more efficient might be one way. You never know whether these things are going to help with that, but maybe.
Thanks.
I don't know about the UK, but at least that's what we're seeing here.
Mika, I assume that a lot of people also did not predict that we're going to have this economic crisis and these problems, right?
No, I think a lot of people saw that building with a zero interest rate or negative interest rate for several years, oversupply is one of the problems that we are having. It's really some people don't want to, probably, when things are going well, they don't want to kind of probably take a look at the worst possible scenario. But it might be that some of the crisis points were not known. Yeah.
And that could have been easily predicted with AI, isn't it?
Yeah, I think so. We've run some tests, obviously, in hindsight. It's always easy to argue that we would have known these things. But I think that when we backtest some of the issues, they should have been in general knowledge as well.
Yeah.
Thank you, guys. I'm going to call a timeout. Let's leave something for the discussion part, because we are right on schedule. So thank you, Mika. We will move forward. And now we have Richard Saldanha from University Lecturer in Machine Learning and in the Queen Mary University of London. So Richard, the stage is yours.
Thank you very much. Let me share my presentation. Here we go. So let me start with an apology. Olen pahoillani, mutta esitelmäni ole Suomen kielillä.
Very good.
I've been practicing that. So, deep learning in real estate investment, myth or legend. What I'm going to do is take you through deep learning very, very quickly. Perhaps a little more detail than Mika's gone through. He essentially touched on things at a very high level. Then we'll just have a look at sort of valuation and prediction from a real estate point of view, property valuation, how I might go about using AI ML for estimating macro trends, economic forecasting, and then beware the hype. And in fact, my presentation, I do sort of warn against sort of blithely relying on models. And then there should be some time for some questions, and I'll make a few comments at the end. So what is deep learning? Well, essentially, we're talking about neural networks. Neural networks, typically anything beyond a single hidden layer is typically referred to as a deep learning system. And essentially, this phrase, deep learning, was literally adopted by the community after neural networks sort of failed to live up to their expectations in the later 80s, early 90s. Once upon a time, they were sort of seen as a bit of a panacea, that basically I could just throw data at a computer. I could fit a neural network. I don't need to worry about the magnitude or direction of parameters. Literally, the computer does all the work and out pops a model. Well, actually, reality is somewhat different. You do need to be very careful in sort of fitting these networks, etc. They are a bit of a black box, of course, because you have so many parameters that it's incredibly difficult to sort of decipher what's going on. And if you've got a large language model, you've got many billions of parameters, so it becomes pretty insane. But that's essentially deep learning in a nutshell. And what we found is that these very large over-parameterized models with billions of parameters are extremely good at learning hierarchical representations of complex data, particularly language. Do a really good job of it. Don't actually know quite what is encoded, but the results are really impressive. So let me take you through a simple language model. So in 2 slides, I'm going to explain to you sort of large language models. And what we can do is we can start with the data set. So there's a classic US baby names data set. So these are baby names given to children in the US. And what we can do is we can examine the 2-letter pair combinations. So we have things like Ada and Daisy, so on and so forth, Elizabeth. And what we'll do is we'll sort of cycle through these 2-letter combinations. So building up EL, LI, etc., spelling out the names on a 2-letter basis. And what we can do is we can basically count these pair combinations. So we can form a grid. If we take the sort of 26 Latin letters plus a full stop, because we need that in order to sort of start our string and end our string. And we can look at that 27 by 27 grid. And that's the blue grid that you can see here in the background. And what we find immediately is that certain pair combinations appear really frequently and others less so. In fact, we do get some zeros as well. We'll use a bit of regularization in terms of our model fitting to get around that problem. But you can see immediately that those data have structure. So that that text data has structure. Now, just this green grid here is just is 9 by 9, and what I'm doing is I'm just sort of zooming in on it. But what we have now, I've converted these counts to probabilities. So basically just normalizing by taking the row sums. And so I've now got rows of probabilities. And so all I've done is I've said that the letter combinations that occur quite frequently have a higher probability. So they are the darker green. So for example, BE occurs sort of 25% of the, not 25%, 0.25% of the time in terms of this data set. And so now I've got probabilities, I've converted them to probabilities. I can actually fit a probability model to these data. Well, in fact, we've got perfectly respectable multinomial distribution. I can fit multinomial distributions to each of the rows. And that's just a standard statistical model. And I can fit that using something like maximum likelihood estimation. And lo and behold, I now have a model that is capable of generating new names. And that's just a standard statistical model. If I want to use a neural network, I can do that as well. So for example, to fit a neural network, all I need to do is define a loss function and define the architecture of the model. So that basically my nodes, the number of layers, etc. And I can fit that model. Well, I can fit that model to a loss function that I've defined via the statistical model. So again, maximum likelihood estimation, the objective function is actually a likelihood. And that likelihood allows me to define a loss. And all I do is I fit that neural network using that loss function. So I aim to minimize loss or aim to minimize the negative log likelihood for those of you that are familiar with that. And so fantastic, I've now got a neural network model. Why do I bother with the neural network model? Well, it allows me greater sophistication because the bigram model, or two-letter pair combinations, doesn't extend very readily. And I can use these activation functions, which you may have come across. This sort of sigmoid is a very nice shape to use. ReLU is a simplification, essentially, of the sigmoid, which is better from a computational point of view. But it allows me to now inject some nonlinearity in terms of my model fit. So I have a more flexible model fit. And here we are. Here's a bit of Python, and this is actually spitting out sort of some names that are existing in the data set, Devon and Geordie, and others that are made up, effectively made up or generated by this very simple bigram language model. But the key point or key points are this. I am taking text data. I have to compute with numbers. I can't compute with text. And so what I've done is I've turned these into probabilities. I've encapsulated the structure in my data set in terms of probabilities, and I'm using those probabilities to drive the generation process. And that's the key to sort of large language models in general. So we can take we can look at a more complex example. So here I've got a Shakespearean data set, 40,000 lines from a variety of Shakespearean plays. There are 1.1 million characters in the data set. We now have punctuation, so I've increased the vocabulary. When I turn letters into numbers, we talk about tokenization. You may have heard this phrase used in terms of large language models. I tokenize my data. It's actually an encoding. It's actually quite relevant for the output that I get at the end in terms of a large language model. But basically, I turn it into numbers. I apply what's known as the self-attention mechanism, which actually is just a little bit of linear algebra, but is a key component in terms of our large language model sort of architecture that we've got. And you may have come across Vaswani et al.'s transformer architecture, essentially the neural network configuration. So that combined with the self-attention mechanism and my encoding of my text, or tokenization of those data, is really quite powerful. I can still use actually this trivial model here, this bigram model. I can just consider 2-letter pair combinations. I can apply that and I get something that looks rather sort of Shakespearean. If you look at it in detail, you'll see that actually it doesn't make a lot of sense, but it's got the look and feel of Shakespeare. Well, this didn't use sort of, a cluster of NVIDIA machines to build. This was 20 minutes of training on an aged machine. I'm just showing you the components that sort of go together to sort of form these large language models. And you can see that now, if I take a chunk of the internet and I tokenize that, and I apply this architecture and a more sophisticated neural network model, I'm probably going to get something quite good. I could probably generate a sort of Llama 65 billion parameter model with a largely this sort of setup, more sophisticated model fit, and a lot more training. Fairly easily, although it probably cost me in the region of $4 million in order to fit that model. But that's the idea. Full credit to Andrej Karpathy here, because I've cribbed shamelessly from his work, and he was one of the guys that was he's one of the co-founders of OpenAI, and one of the key developers of Tesla's driving system. He's a neural networks person. So let's move on to Tesla, caveat emptor. The problem with neural networks is that they are, and this is what we're essentially fitting here, this bigram neural network model. They're notorious for hallucinating. And if we put this sort of system in a car, and by the way, the same type of system, neural network system that runs your large language model, is basically doing the image recognition in terms of your car. And this is an 8-car pileup that occurred in November 2022, and it was a Tesla in full self-driving mode that suddenly switched lanes abruptly and slammed on the brakes, and of course traveling at about 60 miles an hour, and it caused this pileup. Thankfully, no one was seriously injured, but this is the issue with sort of self-driving systems at the moment, and it's not this sort of rear end type collision is running at about twice the level of human drivers. All well. I mean, this is pretty hazardous, and if you read what Mary L. Cummings, Missy Cummings says, one of her statements is that while a language model may give you nonsense, a self-driving car can kill you. So have a look at her material. She's a former F-18 US Navy fighter pilot. She's actually an engineer and a university lecturer now. So coming back to sort of language models, one needs to be very careful, because in the same way that our driving system hallucinates, our large language model hallucinates. And you see here that this is some material from Google's BARD, and factually it is there are lots of inaccuracies here. So there's a reference here to Mr. McCarthy being credited with creating the term artificial intelligence in 1955 in a proposal for the Dartmouth conference. The Times did not cover the Dartmouth conference at all, so there was no article at all. It's sort of completely fictitious, so on and so forth. In the interest of time, I'm going to move on. But basically, if you're uninitiated, you can be fooled by these things. And so the best people at using sort of large language models tend to be people who are expert in their own areas. So we're meant to be talking about real estate investment. So let's sort of dig into that. Now, Mika has touched on a few of these things. So in terms of sort of property valuation, there are a number of companies involved in using essentially neural network image analysis, so to analyze property photos. So House Canary for US institutional investors, REIT providers, real estate investment trust providers, and buyers. Walker and Dunlop, also aimed at sort of institutional buyers, portfolio managers, in terms of sort of using these techniques, neural networks. Walker and Dunlop also use natural language processing. Again, we're talking about a neural network architecture or neural network architectures in order to do that. The aim is to come up with essentially an automated valuation model to assess property value, typically from the condition, quality of finishes, from the image. We might glean information from a natural language processing point of view in terms of I mean, if you were a buyer of property in order to rent out, you might look at rent and financials. You know, the quality of tenants, perhaps in a certain region. Essentially, these are pretty good guides in terms of sort of property valuation, but they aren't foolproof. I'm going to sort of, suggest later that a human in the loop is an essential thing to have when it actually comes down to that transaction. Mika mentioned Zillow's estimate, quite widely used actually in the US. Notably, I mean, there is a couple of things here. There is an error rate associated with all these estimates of value. Nothing is foolproof, as it were, and the Zestimate can't be used as a basis for a loan. It can only be used as a guide. And then in terms of sort of macro trends, we've got an awful lot of satellite data these days. Two examples, Privateer and Earth Daily, both supply satellite image data and analysis for real estate investors. This can provide useful macro insights. Also risks. So, for example, we could identify cranes. We could look at new building developments and supporting infrastructure to sort of assess the pace of development in the geography and indicate sort of future supply. We can look at cars, major retail centres and industrial parks to measure consumer activity and commercial health. We can monitor the expansion of residential areas to identify long-term growth corridors, etc. And evidence of climate change is an important element in investment decision making now. So fire and flood risk assessment, particularly using satellite images, remote sensing, can be extremely useful. Just touch on another example. Placer AI is concerned with foot traffic and human mobility analysis. So basically, our mobile phones have the ability to supply a lot of data. When aggregated, this is potentially really quite useful information if I want to build a machine learning model. And it might help me to answer questions such as which neighborhoods are attracting the most new residents. Are suburban shopping centres gaining traffic at the expense of urban ones? Those sorts of questions. In terms of economic forecasting, well, I mean, this is a broad area. This is something that we do beyond, we'd like to do sort of beyond real estate investment. And here again, we're sort of back to large language models. If I want to sort of incorporate non-linearity into my models in particular, and things like long short-term memory and gated recurrent unit models. These are neural network architectures, have proved to be fairly useful in terms of analyzing time series data. We can use natural language processing to scan sort of news articles, planning documents and earnings call transcripts in order to sort of get at additional insights, maybe be ahead of the curve in terms of what's going on. And by the way, when I present large language models to my students, I refer to them as modern day natural language processing. Natural language processing has been around as a subject area for quite some time, but large language models essentially are really skilled at carrying out those NLP tasks that people have been working on. And so yes, I mean, very, very, very useful. These tools, and I think you should view them as essentially tools, are very, very useful in terms of sort of guiding people from an investment point of view. And I'll just touch on sort of nowcasting, which is prediction of the very recent past or the present, and can handle sort of a ragged edge data set, particularly useful for economic indicators, say GDP, which tend to be lagged indicators. They tend to be backward looking, etc. I might be able to come up with an estimate of GDP based on what I'm observing in terms of shorter term data. So maybe tech sentiment, satellite data, monthly employment figures. I can basically combine these various measurements together, produce a synthesized update on, say, a published statistic that might be really useful for my investment decision making, but isn't available just yet. Beware the hype. So there's a huge amount of hype in terms of AI currently. Classical maths, statistics, and computing still powerful today. It doesn't need to be, nor should we pretend that it's all AI. Although if you're a tech investor, if the investment in front of you doesn't use the word AI, it's very difficult to make that investment at the moment. We still live in a binary computing world. I want to make that point, despite the promise of quantum. Quantum is a bit of a pipe dream at the moment. We do have analog chips which have a graded response, would you believe, but they tend to be somewhat unreliable because they rely on sort of solid state electronics. Binary computing is where we're at, and it's wonderful what we can do with it. I've just thrown this in. Remote sensing, if you might, today we have satellite images, but remote sensing began with the first aerial photograph. That was way back in 1858. That's a shot of Paris taken from a balloon. And any model, doesn't matter how sophisticated it is, can be brittle. And economic models, in my experience, are particularly so. So do sort of beware. Anyway, in the interest of time, and I hope I haven't overrun too badly, we still need to exercise our brains with whatever we use. And my belief is that a human in the loop is still a very powerful agent. And it's useful to have some understanding of what underpins software, AI or other. And so this is a worthwhile exercise. Data quality and integrity are hugely important, as always. Garbage in, garbage out is as true today as it has always been. Anyway, myth or legend? I leave you to decide. We can speak a bit later. Thank you.
Thank you, Mr. Saldanha. And now we are running a bit late, but nothing to worry about. And there's time for maybe one question, perhaps from somebody in the audience, because we have reserved some time for discussions with Mika, Lawin, and Richard. If there's any questions in somebody from the audience, maybe now is your chance, or you can ask them later. I see no hands, nobody's speaking out, so we will move forward. So our next and final speaker, and I have to apologize if I butcher your name, I'm sorry, but Mr. Lawin Chandra, he's the author and CEO and the founder of aiRaiz. Hopefully I got it right.
Yeah, aiRaiz is correct. Thank you so much.
Okay. Please.
Richard and Mika, thank you also for your presentations. They were very insightful. I'm picking up a little bit more on Mika's points, and I wanted to speak about some of the case studies, what we see at the moment in the market, what's going to happen. And I wanted to speak about market predictions using AI, portfolio optimization tools, transforming transactions, AI-enabled deal sourcing, and finally also AI-enhanced negotiation tools. A little bit more background about myself. I'm not from the academic side. I studied private investment market at Oxford, and then I studied artificial intelligence. also at Oxford. And I utilized all this knowledge and implemented this straight into my startup. The startup is now represented in 3 continents. We have an office in San Francisco, in London, and soon also in Singapore, but we already have some people over there. And 80% of our clients are from the real estate industry, and we can already see what's actually working and what's not working. And we see some general partners and asset managers starting to implement more and more AI technologies to somehow deliver alpha, if we can call it, for higher returns than the average. I have around $7 billion in real estate transaction experience, and now also in private equity, venture capital, and infrastructure. And with this company and within my career, I've raised a little bit more than $700 million for my company and also for my clients. Let me go into the market prediction area, which Mika addressed at the beginning. So the ability to predict market trends accurately is fundamental to successful real estate investments. Historically, this process has relied heavily on intuition and localized expertise and time-intensive data gathering. AI, particularly generative AI, has transformed this process by enabling the comprehensive analysis of macroeconomic trends, property market fluctuations, and demographic shifts. This technology advancement allows investors to anticipate changes and capitalize on opportunities that would otherwise remain hidden. Generative AI excels in synthesizing macroeconomic data from diverse sources such as GDP growth rates, employment statistics, consumer confidence indices, and inflation trends. By correlating these indicators with historical property performance, AI systems identify regions with strong economic fundamentals that are poised for growth. For example, metropolitan areas experiencing robust job creation and population increases often become hotbeds for real estate activity. AI platforms can pinpoint these areas, allowing investors to prioritize high potential markets before they attract widespread attention. In addition to macroeconomic analysis, AI enables a deeper understanding of microeconomic factors that influence local markets. Through geospatial analysis, AI systems evaluate variables such as infrastructure development, transportation connectivity.
Excuse me,
and
sorry to interrupt you, but are you showing us slides because we are not showing?
No,
Okay, good.
I'm just speaking.
Okay, I just wanted to make sure. I'm sorry.
Okay.
Continue.
Yeah, so these insights are invaluable for identifying neighborhoods or properties that are likely to experience increased demands. For instance, areas near proposed transit lines or upcoming commercial developments often see significant property value appreciation. AI tools can highlight such opportunities well before these changes are reflected in market pricing. AI's ability to analyze demographic trends further enhance its predictive capabilities. By examining data on migration patterns, population age, distribution, and household income levels, AI systems can forecast shifts in housing demand. For instance, during the COVID-19 pandemic, many urban residents migrated to suburban areas in search of larger homes and outdoor spaces, driven by remote work and lifestyle changes. AI platforms identified this trend early and enable investors to pivot their strategies towards suburban markets. This foresight not only allowed investors to capitalize on growing demand, but also mitigated risks associated with urban property or declining urban property values. Another significant advantage of AI in market prediction is its ability to operate in real time. So traditional market research often lags behind current developments, but AI systems continuously update their models with the latest data. This dynamic capability allows investors to respond promptly to emerging trends, such as policy changes or unexpected economic events, which Richard also indicated. For example, when governments introduce tax incentives for affordable housing or implement new zoning regulations, AI systems can quickly identify affected markets, enabling investors to adjust their strategies accordingly. The integration of AI into market predictions also support the identification of underperforming assets with latent potential. By analyzing historical pricing patterns, AI can detect properties or neighborhoods undervalued due to temporary market inefficiencies. Investors armed with these insights can acquire assets at favorable prices and unlock value through targeted interventions such as renovations or repositioning. Let me elaborate a little bit more now on the portfolio optimization tools, which Mika indicated. And this is focusing very much on machine learning algorithms, which are already available on GitHub libraries as an example. So machine learning algorithms evaluate risks, predict returns, and recommend portfolio adjustments based on changing market conditions. While market predictions and trend forecasting focus on identifying opportunities, risk assessment is critical for sustainable real estate investments. The predictable nature of real estate markets, influenced by economic cycles, regulatory changes, and external shocks, makes effective risk management essential. Machine learning, a subset of AI, actually offers powerful tools to evaluate risks, model scenarios, and optimize portfolios for resilience and profitability. Machine learning tools excel in scenario simulations, enabling investors to evaluate the impact of various economic conditions on their portfolio. By modeling thousands of potential scenarios, these systems provide a probabilistic view of risk and opportunities. For example, an AI model can simulate the effects of rising interest rates on property valuations, rental income, and financing costs. Investors can use these insights to develop contingency plans, such as refining strategies or cost adjustments to maintain portfolio stability. This was also the point when I mentioned to Mika that this could have been, or the problems which we have now in Finland with the real estate market could have been identified way ahead. The dynamic annotation is another area where machine learning is transforming portfolio management. So unlike traditional approaches that rely on periodic reviews, AI systems continuously monitor asset performance and market conditions, providing real-time recommendations for rebalancing. For instance, if market data indicates declining demand for retail properties in a specific region, an AI system might recommend reallocation funds to sectors with stronger growth prospects, such as logistics facilities or multifamily housing. This proactive approach ensures that portfolio remain aligned with changing market dynamics and investor objectives. One of the most important applications of machine learning is in identifying correlations and diversification opportunities. A well-diversified portfolio reduces the exposure to market-specific risks, and AI tools analyze the relationship between different asset classes and geographic regions to recommend optimal diversification strategies. For example, an investor heavily exposed to urban office spaces might receive suggestions to diversify into suburban residential properties or industrial warehouses, which offer different risk-return profiles. By mitigating over-concentrated risk, these recommendations enhance portfolio resilience. Machine learning also facilitates the assessments of less obvious risks, such as environmental and climate-related threats. By analyzing data on historical weather patterns, flood zones, and building resilience, AI tools can flag property vulnerable to natural disasters. Investors can then factor this risk into their decision-making, ensuring the properties are adequately insured or retrofitted to withstand potential damages. This capability is increasingly important as climate change continues to worsen the frequency and severity of extreme weather events. Another critical application of machine learning in risk assessment is its ability to detect early warning signs of market downturns. By analyzing leading indicators such as construction activity, vacancy rates, and financing conditions, AI systems can identify market at risk of oversupply or declining demand. These insights allow investors to exit or de-risk positions in affected markets, protecting their portfolios from significant losses. Beyond risk assessment, machine learning tools enhance performance monitoring and benchmarking. Investors can use AI to track key performance indicators across their portfolios, such as occupancy rates, rental yields, and maintenance costs. These metrics provide a clear picture of asset performance and highlight areas for improvement. For instance, an AI system might identify a property consistently operating below market rates, prompting the investor to implement price adjustments or marketing campaigns to improve occupancy rates. Machine learning also automates many routine tasks associated with portfolio management, such as data collection, analysis, and reporting. This automation not only reduces operational costs, but also frees up valuable time for investors to focus on strategic decision-making. Additionally, the transparency and objectivity provided by AI-driven insights build trust among stakeholders, including institutional investors and lenders, who increasingly rely on AI-generated data to guide their decisions. While machine learning offers significant advantages, it is essential to address the ethical consideration and limitation associated with its use as well. For example, biases in historical data can lead to skewed risk assessments or flawed predictions. Ensuring that AI systems are trained on diverse representative data sets is critical to maintain fairness and accuracy. Similarly, the reliance on AI-generated insights should not replace human judgment, as Richard already indicated, but rather complement it, enabling a more holistic approach to investment decision-making. Well, in summary, AI technologies, including generative AI and machine learning, are revolutionizing the real estate investment analysis by providing advanced tools for market predictions and risk assessments. These technologies empower investors to navigate complexities with greater precision, uncover hidden opportunities, and optimize portfolio performance. By integrating AI into their strategies, investors can enhance their decision-making process, improve resilience, and achieve superior outcomes in increasing competitive markets. As AI continues to evolve, its role in real estate investment will only deepen and drive innovation and setting new standards for excellence in this industry. Now I would like to speak about the transforming transactions which AI is enabling. So I've done quite a lot of transactions, and I would say AI is redefining the landscape of real estate transactions, not only in the States, but also in Europe. It's a domain which is traditionally characterized by its complexity, time-intensive processes, and reliance on human expertise. From sourcing deals to negotiating the terms, generative AI and machine learning technologies are automating, enhancing critical aspects of real estate transactions. This transformation is streamlining workflows, reducing transaction times, and providing data-backed precision that minimizes the risk and maximizes actually the values for the buyers and sellers. One of the most impactful application of AI in real estate is in deal sourcing and negotiation, actually, where it enables investors and stakeholders to navigate the complexities of transactions with unmatched efficiencies. Hence, it is revolutionizing the real estate transaction process, which has historically been characterized by inefficiencies, manual tasks, and complex negotiations. From deal sourcing to finalizing the agreements, AI has introduced tools that automate and enhance critical aspects of transactions, providing first-time efficiencies and accuracies and also strategic insights. In terms of the AI-enabled deal sourcing, this is a process where it has been always resource intensive, involving time-consuming researchers, extensive market research, and the reliance on industry networks. AI has transformed this aspect again by automating searches and identifying opportunities that align with specific investment criteria. These criteria may include geographic location, property type, financial metrics, and also risk tolerance. AI platforms leverage machine learning algorithms to scan massive data sets, including property listings, zoning information, and market reports to deliver tailored recommendations what to buy, what not to buy. A significant advantage of AI in deal sourcing is its ability to uncover opportunities that may not be visible through traditional methods. For instance, AI tools analyze data points such as historical property performance, demographic trends, and economic forecasts to identify undervalued or off-market properties. These platforms also integrate geospatial analysis, which examines factors like proximity to infrastructure, amenities, or commercial hubs. By synthesizing this data, AI provides a comprehensive view of potential investment opportunities. AI systems also offer real-time updates on market conditions, enabling investors to stay ahead of the trends. Unlike traditional market analysis, which often lags behind current developments, AI tools continuously refresh their models with the latest data. This dynamic capability allows investors to respond promptly to change in market sentiment, government policies, and also economic conditions. For example, when a new zoning regulation increases development potential in a specific area, AI platforms can quickly flag properties affected by the change. And finally, I would like to speak about the negotiation tools a little bit more in detail. Negotiation is a cornerstone of real estate transaction, requiring a very deep understanding of market conditions, property valuation, and contract structures. AI has introduced tools that augment the negotiation process by providing data-backed insights, automating routine tasks, and identifying risk embedded in complex agreements. One of the most transformative applications of AI in negotiation is contract analysis. AI-powered systems can parse lengthy legal documents, extracting critical clauses, identifying consistencies, and flagging potential risk. This automation reduces the reliance on manual legal reviews, saving time and minimizing the likelihood of errors. For instance, an AI tool might highlight clauses related to maintenance responsibilities or environmental liabilities in a lease agreement, enabling the negotiating parties to address these issues proactively. Pricing analysis is another area where AI significantly enhances negotiations by evaluating comparable property transactions, rental income projections, and market trends. AI tools generate data-driven pricing recommendations out of these metrics. These insights help investors to structure offers and counter offers with greater confidence, ensuring the pricing decisions are aligned with both market conditions and also financial objectives. In competitive markets, this precision can be the difference between securing a deal and losing out on to a competitor. AI also supports negotiation by simulating different scenarios to their potential outcomes. These tools model various deal structures, financing arrangement, and contingency plans, allowing stakeholders to evaluate the financial and operational implication of each scenario. For example, an AI platform might simulate the impact of different rental escalation clauses on cash flow, helping the negotiation parties arrive at mutually beneficial terms. Moreover, AI-driven negotiation tools enhance collaboration among stakeholders by centralizing data and simplifying basically the communication. Complex real estate deals often involve multiple parties, including buyers, sellers, legal advisors, and financiers. AI platform consolidate relevant data into intuitive dashboards, providing a single source of truth for all stakeholders. This transparency ensures that everyone involved has access to the same information, reducing misunderstandings and facilitating faster decision-making for all stakeholders. I hope I'm still on time, Jaakko.
Yeah, great, thank you. It's not your fault, we are just running a bit late, but we had 15 minutes for discussion, and I think we could go straight to the questions, because I think there are a few questions from the audience. So anyone, if you have a question for Lawin or Richard or Mika, now is your chance. Just open your microphone and state your question, or raise your hand virtually.
I should mention here before the questions that Lawin has a new book out. It probably didn't mention that, but it's a wonderful book, AI Innovation in Real Estate. Highly recommended, and he's modest, but he's a recent author, especially in this field. And when you ask, remember, Richard also has decades of experience in the City of London for asset management and various roles, so he has a lot of insight.
Thank you, Mika. I have a question to the audience, actually. So what do you guys think is the most important aspect in AI and real estate?
It's a tricky one.
Yeah, I think that
Here we go.
I think there's a difference between academics and practitioners.
Yeah. Please, Osku, go ahead.
Hello, my name is Osku Toro, and I'm Mika's colleague from Tampere University. In our projects, our view of AI is to use AI as the ultimate data integrator. Instead of using AI in the siloed use cases, siloed models that is connected to the siloed data sources, we use AI's ability to connect the user and the multiple different data sources. And this was also my question to Richard and Lawin, and how do you see this AI's value as a data infrastructure that connects different data sources together? How do you see that in investing?
Richard, do you want to go first?
Yeah, okay. I mean, we talk about sort of pipelines, building blocks of these technologies, then I think that's actually, I see that as master building in itself. And I think that is quite a nice approach, actually, because I think let's leave it to the tech companies in the US to sort of actually build those large language models. I'm very much a user of this technology. We can use, there's LM Model Studio, for example, where you can play with small language models. You can fine tune a small language model. You can combine them with other elements, building blocks, etc. I mean, I see that as a really good way forward, in that your solution is then more targeted and you reduce the risk of it actually leading you to make stupid decisions from an investment point of view.
Let me clarify your question, Osko. Are you interested to understand how to utilize the data from different silos, or are you more interested to understand how a company or a startup is evolving from a normal company, service providing company, to a data company?
How do you utilize AI to connect the different data silos? Because data silos is a universal problem in every project and in every organization. And our view of using AI is just handling data silos and specialized agents and handling the data sources properly with high quality data and so on. So using AI as a data integrator, basically.
Okay, so the way we do this, first of all, I'm not doing it. My PhD AI developers are doing it. And we have different problems here. First of all, the real estate industry is not generating enough data. And then I'm also in the private investment market, which is very secretive and it's not giving out a lot of data. So data scarcity is a big problem we have. But once you have the data, you should try to utilize some of the APIs to connect the data sources, and then I think one of my developers are using SQL or SQL to source the data, have it in our AWS infrastructure, and then review and analyze these data points. But we have only 10.5 million data points, which means of every LP investor, we have around 150 data points, which is actually sufficient in order to make an analysis whether an investor is suitable or not. And that's a very low amount of data. In general, for LLMs or any other machine learning algorithms. However, it's a huge amount within our real estate industry because it's very difficult to obtain data. One of the solutions which we are now implementing is synthesizing the data. So if there's no data about a certain data point of a certain investor, we are predicting what could be the data point of a specific investor. And believe it or not, it's very powerful, the synthesized data. And this simply means that our real estate industry can actually go out and compete with the finance industry. Because the finance industry, you, Mika, you're doing this with your company, is providing data on a second by second basis, whereas our real estate industry, either we get it from a micro point of view, from HVAC data, elevators, and so on. Then we can analyze this from a micro point of view, and then we can combine it with a macro point of view, government policies and so on, which is also very, very slow. But if you're synthesizing this with certain machine learning algorithms, we can combine it and utilize data. We are also debating at Oxford for our company, should we use collaborative filtering, content-based filtering? And then we decided at the end that we use content-based filtering in order to use the profiles of other LPs and to profile it to those LPs who do not have data.
Thank you. That's excellent answer for my question. Thank you.
Any other questions? I actually do have a question for Richard. It's more research oriented, and we are kind of what we're seeing now directly connected to what Osko asked, what Lawin described there. We're seeing a lot of proprietary data and held by private companies. And from the research point of view, that seems, and from the kind of democratic point of view, that seems kind of not scary, but just not optimal in a way that large corporations hold the data, obviously their own data, tightly and can compete in the fields and with the AI and with the tools that the other people can do. Do you have any kind of, from the London perspective and from the university perspective, a view on the use of private data and just so that it might be a problem. We've seen that in with the platforms, WhatsApp and Facebook and all of that hold a lot of private data.
Yeah, I mean, if we're talking about investments and talking about private equity in particular, I mean that is intellectual property in itself, the data. I'm not surprised that is maintained privately. I don't think we can criticize investment firms who treat those data in that manner. Obviously we want them to share it with their investors, etc. And I do still have a hand in private equity from an investment point of view. I wear a particular hat in one of my non-executive roles that I hold. In terms of, I mean, Lawin, in terms of sort of proxying data, which I think is what you were getting at, I think that's a hard ask, even with, and I don't think AI necessarily solves that problem. I mean, that really is you're really taking your heart in your hand there if you're going to try and do that. I mean, the confidence intervals around any sort of estimate like that have got to be very wide. So not quite sure what to do there. So, but coming back to Mika's question, to be honest with you, and maybe it's not the answer you want to hear, I think it's entirely appropriate if depends on the type of data. If I'm a private equity manager and I've got very selected investors, then I am going to be very careful about those data and who sees them. Remember that I may be funding sort of infrastructure projects. They may be they're typically highly confidential. These aren't public markets. They're private markets, etc. And I probably want to keep them to myself. However, if we're talking about data that Facebook or X hold, then that's a different story. Then it's rather sinister that they have aggregate data on all of us. Although I've never had a Facebook account, I think one of the few people on the planet that hasn't, and they're using this effectively as, I mean, it's not against us necessarily, but they're using it in order to add value to their companies. Now that's a different story altogether.
Yeah, I think I would answer this from a different perspective, maybe more from a B2B perspective instead of B2C, which is the area of my expertise. So there are different evolutions for a startup or for a company. When they start, they might think about, okay, let me provide a service. It's the first stage, and they might not use that much of technology. But then they evolve into the next stage where they say, okay, we are digitalizing a lot of the areas. We are utilizing data and AI nowadays as well. And then they are highly digital platform instead of a simple service provider. Let's call it a SaaS, software as a service platform. But from that moment on, you're moving to the next stage, the third stage. And that is when this company suddenly is able to collect so much data that they actually become a data company instead of a service company. So you see the movement from a service company to a SaaS platform to a data company. Now they have all the data of that industry. And what they then do is they say, okay, instead of selling our service, we are selling our data. All the market participants and stakeholders, they say, okay, this one company has such a sophisticated data lake. If we have access to this, we have a competitive advantage towards our competitors. So we buy the data from them and we provide our service. And I think this is the evolution which a lot of companies are doing, including us as well.
Thanks, Lawin.
Thank
We're
you.
almost at the end, right? Jaakko, please.
Almost.
Yeah. So I want to hear last word, at least from Lawin and Richard. If anyone wants to come in, please do. What's going to be the next step in the markets for real estate investing? How do you see that from a personal perspective? Or kind of really brief comments so that we know where we're heading now.
I think I can answer this very quickly. We have been at a stage of very low interest rates. So equity investment was very popular. Then suddenly interest rates have increased, and investors such as family offices, pension funds, sovereign wealth funds wanted to lock in these interest rates and receive very high annual returns and yields. But now we are again moving towards a scenario where interest rates are being lowered by the central banks, and then you are not able to lock in these let's call it high interest rate. In reality, it's normal if you're looking at this from a 50-year perspective. Then equity will start to become interesting as well. Now we have also other scenarios, and the States is way ahead of Europe in that, where we had a lot of problems where companies did not predict that the interest rates are going to change. They have at the moment very bad debt service coverage ratios. They cannot serve the interest rates, and they haven't forecasted this. They haven't implemented any operations on that. Some of them will go bankrupt. Some of them have to sell their assets. So new market participants will come in, will work extremely hard on their operation to obtain these kind of investment opportunities and capitalize on this current market trend. So equity will become interesting again for the market.
Mika, were you asking from a markets perspective? I thought you were asking from an AI model perspective. Oh, you're on mute.
Mostly about markets. What's the next big thing?
Well, I mean, in the UK, we've enjoyed low interest rates, as Lawin has mentioned. Prices are coming off. We've got higher interest rates. I think we benefit hugely from our housing stock in terms of the valuation of the UK as a whole from a GDP perspective. If the housing market comes off, then I think it's looking quite shaky from a UK economic point of view. I'm not in the business of crystal ball gazing, but we're seeing some of the same problems that you're experiencing in Finland, driven by this. The difference is we don't have oversupply of housing stock. We generally have undersupply in key areas, but London is the population of London is actually falling. People are moving out of London, not in droves. I don't want to give the wrong impression here, but that is having an effect on the housing market. I don't want to get political. I'm not going to talk about the policies that the current Labour Party have instituted. That's not really my bag. But it's not great from a general housing point of view.
Thank you.
I would also add to that one before we finish up. I think what you should look at is really where is the demographic positive. So where are more people moving in? Cities have always been a hot topic. Cities are getting bigger and bigger. Villages are getting smaller and smaller. Might be a big problem because Finland is a huge country with Helsinki, one major city hub. So you have to be very careful when you're investing into a village. But then you have to also look into this from a global perspective and look into countries such as Indonesia, where the population is growing heavily. Nigeria, and if you're able to navigate the micro policy and so on, then you should be able to make a good investment over there. But my last question was, what do you think is the most important aspect in terms of AI investment or AI in real estate? Anyone?
Well, I'll go. I think I don't see new models. What I see is a refinement and an improvement of what we've currently got, particularly around data quality, actually. Well, that's a brief reply. We have someone with a hand up here.
We have Juha from Italy.
Finish from Italy, but yeah, probably I circle it back to the sustainability issues that we are facing currently at the global level, and real estate stock is one of the core contributors here, and at least in the Finnish, still the operational emissions are quite much higher than the embodied carbon, and we are trying to solve this through multiple different hybrid energy systems where you could turn the real estate stock into energy producers, but this is quite difficult due to the fact that the design values usually don't match the operational output of the building and the energy systems. So probably this should be one avenues for the AI to help to generate some kind of operational like energy production and consumption like solutions that would help these hybrid systems to operate in the designed way.
Thank you, Juha. Richard or Lawin, do you want to comment on Juha's question or comment?
Lawin, you have anything here? You look as if you're going to say something.
I think it includes my perspective on what's the most important aspect in AI. Let me just tell you, I think it's adaptation. Adaptation is the most critical aspect. I've learned at Oxford, it's data, but even if you have the data, even if you have the models, even if you have a solution for ESG and climate change, if the people within our industry are not adapting to the new AI models, to digitization, then you can code, you can have the best solution, but it's never being used. And the statistics at the moment, which I've heard at a lot of conferences in San Francisco, in London, and in Asia, is 80% of the AIs and the software which we are developing at the moment is not being adapted. The solution, in my opinion, is a top-down approach where the CEO has to be a dictator and say, okay, everybody within the company has to use the new AI technology, and every client has to use the new AI technology, or every client has to use a solution which Juha has developed for climate change. If not, it's not going to work.
Yeah. Okay. I mean, I did work on a project at the Turing, which was transition to net zero. It was a reinforcement learning project, somewhat stylized, etc. We set it up as a competition. So how can you achieve sort of net zero by 2050 by optimizing the energy mix whilst sort of maintaining jobs? So we looked at that as a constrained optimization problem, essentially, and that's what Juha, I think, is sort of suggesting here in terms of house build. I think, in short, it probably adds more constraints to the building of homes. Of a building of any sort of or offices as well, factories in Finland. It's a tricky problem to try and model, full stop. But I mean, that doesn't mean we shouldn't try.
Thank you. Unfortunately, we are running out of time. We ran out of time 10 minutes ago, but it's a very nice discussion. Unfortunately, I think we have to stop here because it's a Friday afternoon, and I think a lot of people have work to do before they can get on with their weekend. But once again, I would like to thank all our speakers, Mr. Chandra, Mr. Saldanha, and of course our very own Mika Lehtimäki from Tampere University. Thank you for lending us your time and making this happen, and all the best in the UK. And thank you.
Thank you, Jaakko.
Thank you.